Okay, so welcome back, everybody. Glad to have you all back that are joined from last night, and all the new folks. I'm happy to have you as well. Just a reminder, I've got a couple of our current grad students monitoring chat that are helping me answer questions. Scott and Samson. So please ask questions in the chat if you want. You're also welcome to stop me, and you can raise your hand, and happy to ask questions live as well. And we'll have time at the end as well to talk about more things. So just to go over the agenda for today, we're going to start out, again, we have time right now for questions. So if you have questions, please feel free to jump in. Then we're going to start out talking about Ggplot, which is sort of the modern fundamental way to build graphics, statistical graphics using R. And we'll talk about that for probably 30 minutes or so. Then we'll take a short break, which we can answer questions or talk about other stuff. Then we're going to go into dplyr, which is another one of these core packages in R that are used for a lot of different data management and analysis tools. Then we'll go and change direction a little bit and talk about different R file types, including R projects and interacting with GitHub. Some common packages that I use a lot and I highly recommend. And then we'll have some time at the end for Q&A. I mentioned some of these folks last night. I mentioned this too. This book, R for Data Science, is the absolute fundamental text on learning how to code in R. Yeah, Kara's got one. Its content is 100% free. Scott's got one. Its content is 100% free on the web. I'll put the link in the chat real quick. R for Data Science. The authors made a deal with their publisher to allow for all the content to be published online. It's a lot more updated online, but its core tools it's talking about are Ggplot and dplyr and all the wonderful stuff you can do with it. So the content I'm covering tonight is a small snippet from one chapter of that book, and it goes into a lot more depth and a lot more different things. And I highly, highly recommend it. People that ask me what they need to do to start learning R, I say get this book. And I don't get any money from it, so it must be good. Okay, so to get started today, again, I'm going to put in the chat real quick the notes that I'm looking at right now. Let me do that real quick. Okay, so I just put into the chat this file that I have in front of me. Again, it has all the code embedded in it, and if the raw code that made this document is all written in R. It's on my GitHub site, and if you want me to put that in the chat, I can do that as well. So packages for today. So yesterday we installed R, we installed RStudio. And I have a short script here that lives on my GitHub site. And if you copy and paste that into your RStudio, it says it might take a second, be patient. It'll install a few packages that I'm using tonight. Whoops, got the bomb. It will install a few packages that I'm using tonight, most notably tidyverse and a package called CRAN Task Views, which it'll install several packages. You can see here it's going through and installing a bunch of packages. All of these are things that are either part of tidyverse, because tidyverse is like a suite of packages, or things that tidyverse depends on. So it's going to install all these different packages on your computer. Like I said, it might take a second to do. Okay, and then it's done. And then you can have all the packages that are required to run the stuff that I'm going to show in class today. So one of the notes I got last night was that I talk really fast. So that's true. And if I talk too fast, please don't be shy. I will not be offended if you say, whoa, 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 go back. What did you just say? I talk really fast. So I'm used to that. So the data we're going to be using today come from the 2018 World Population Data Sheet. We saw some of this last session. So this is a lot of key demographic indicators for every nation in the world from the year 2018. And I have it hosted right now. I paid a grad student several years ago to enter the data sheet from the PDF, which I know there's tools to do that, but at the time I didn't know about them, into Excel spreadsheet. Now the data are hosted on my GitHub site, so you can access those directly. And this is what we did last night. We used, so we can load this library readr, which is part of Tidyverse. And within it, we can use the read CSV function, read underscore CSV, and give the URL address of the data file that we want to read. It will read it in, and then we'll have our data at our disposal. So let's just do that real quick. So, so here's our PRB data, 210 observations, 27 variables. I can click on it in RStudio, and I can browse it if I want to. It has a bunch of different indicators for every country in the world. Some are missing, some are, most are present, but some are missing. So now we're going to talk about the key suite of packages that we're going to be talking about tonight, which is Tidyverse. Tidyverse is, it's more than one package. So when you go to R and you type library Tidyverse, it will actually load up all of these packages. So it's actually 7 different packages that are in the core suite of Tidyverse now. Ggplot 2 is grammar of graphics, so how you build repeatable graphics using code. Tibble is a data storage, it's like a more tidy version of data frames. TidyR has a bunch of different data manipulation functions in it. Purrr is a way to do what's effectively known as the MapReduce algorithm. It can take a function and apply it to a bunch of different things at the same time or in parallel. It's really useful. A dplyr is the core package for data manipulation and summary. stringr is a great package when you're dealing with a lot of character data. And forcats is a package for working with character data that are stored as factors. Okay, so they have a special encoding in R. So this is like the core suite of packages that are in Tidyverse. Tidyverse is really, it was first published in 2019. Hadley Wickham is again sort of is the author of this book. He's written several of these packages that are in Tidyverse. He's got an article in Journal of Open Source Software about how these things work together. And so the idea is that we want to try to have a streamlined, literate way to connect data to data summary and manipulation functions to other output. And Tidyverse gives you a lot of different tools to manipulate data, summarize it, and plot it. Okay, those are the core tools we're going to be looking at tonight. And all these things are connected to each other, and they all share very common syntax. If you do if you run my install script from right here, it's going to install Tidyverse on your computer. If you didn't want to do that, you could just do install packages Tidyverse in your R session, and it will install the current versions of all these packages. The workhorse again that we're going to be working at here, especially tonight, are dplyr and ggplot 2. Sources are there. And again, dplyr is really the core of this R for Data Science book that that I've already referenced. And Ggplot 2 has its own text. I don't think I have it here. It's at the office. There's a Springer book, Ggplot 2 Elegant Graphics for Data Analysis, that goes through the whole philosophy of how Ggplot works. And we'll talk about some of that tonight. So let's get started with Ggplot. And Ggplot is one of these things that Ggplot and dplyr both are ways that you can get into R and load data and have some quick wins by making some relatively simple graphics really, really easily. You can take the simple things that we do and build upon them to produce really, really nice graphics. And some of the feedback that I got last night were wanting to see sort of how these things work in a larger project. And I've got a project that I can show you towards the end of the session where produce publication quality graphics for a research project that has all the bells and whistles in them, using dplyr, tidyverse, very similar stuff that we're going to be doing tonight. So we'll take a look at that and see sort of taking this stuff into production. So in general, Ggplot has a few core statements that every sort of plotting analysis is going to have. Your initial first step is going to be a Ggplot statement. This tells R the basic, the data source name, so the name of the data frame that's stored in R. You can identify basic aesthetics. The aesthetics here are, you can think of as X and Y. If you're thinking about a two-dimensional plot, the X and Y, what are the variables that are going to be plotted? Are you going to have data represented by different colors or shapes? All of that can be identified in this step. The aesthetics are defined by this AES function, which identifies the aesthetic. And depending on what type of plot you're doing, different types of plots will require different aesthetics. If you're plotting like a single histogram, it's only going to require a single variable. If you're plotting a histogram that has different colors based off some grouping variable, you have to identify the variable that's being the histogram of, as well as the variable that identifies the grouping factor. So it depends on what kind of plot you want to do as to what types of arguments you're going to enter into this aesthetic function. So once you define sort of the key data and the aesthetics to be used, then we're going to define the geometries. How are you wanting to plot this? Is it going to be dots? Is it going to be X and Y? Is it going to be a scatter plot? Is it going to be a histogram? Is it going to be a bar chart or a pie chart? Or, there's loads of different loads of different geometries out there. Several people on the call have taken my GIS class. You can make maps really, really nicely within R, very succinctly, using what's called a simple feature geometry, which is a way to deal with spatial data. Really, really slick. So there's lots of different plots, different types of plots that you can generate in R. And again, if you work through the online materials of this, you'll get a lot of exposure to a lot of different plot types. And we'll work through a lot of this tonight too. So this will identify, again, this is the geometry layer. So how are you going to represent your data in terms of figures? And then the last thing you're going to be doing are plot annotations. So these are things that they're going to clean up your plot, give labels for axes, give titles, give subtitles. And here you can really do a lot in terms of making special annotations around the plot. And again, later on, I'll show, probably at the break, I'll take the opportunity to show sort of something I did that made a really nice production quality graphic and the steps I took to do that. So now we're going to illustrate some basic Ggplot examples to show a few different plot types and walk through the code on why I'm using different code here and there, okay? So first you're going to load up, Ggplot automatically loads if you load tidyverse. You can see it loads automatically there. Or if you want to, you can load it individually. I usually load just the tidyverse package at once because it's going to load dplyr and ggplot at the same time, as well as all these other helper libraries. So why did that work? Why did that print? Okay, so I did skip it. So what we're going to do here, and we're going to walk through sort of the logic of what I'm doing first, then we'll see the plot, okay? So I have this PRB data that I loaded from GitHub. It's living in my environment right here, okay? So I call Ggplot. I tell it that the PRB data set is the source of the data. The aesthetic I'm going to be using, I'm going to be making a histogram. So I only have to identify one variable, okay? The variable I'm going to be making the histogram of is the GDP per capita, which is what this variable right here is, okay? Okay, that's what I include a plus at the end of the line, and you can see what the code looks like right here. We can take a look at this. So this is my code right here, okay? So I say Ggplot, I identify the data set, I identify the name of the variable that I want to plot, and then I add a plus. Okay, if I could ignore this and just make a quick plot. Okay, well, actually, it doesn't do anything because I haven't identified the geometry. Okay, right now it just identifies that GDP per capita is on the x-axis, but I haven't told it what geometry to use. So it doesn't. It's just like the empty plot right now. Okay, I could do a very, very basic thing where I add a plus, and then I could add this line, which is geometry histogram. So this tells R to take this variable and make a histogram from it. There we go. Okay, so that's how we're building the graph. Identify the data, identify the aesthetic, identify the geometries. Okay. If I want to be fancier, you know, I could just end it there and have my histogram. Again, it depends on what you want to do. If you want to have a very simple graph with nobody knows what this is, that has no title, you have no idea what's being plotted, this is right now, it's not a very effective figure. Okay, so let's add some annotations to make it better. So we'll add another plus at the end of this line, and I can use this labs function. Labs will add labels to the plot. Okay, I'm going to add a few different labels to the plot. I'm going to add a main title, distribution of per capita GDP in 2018. So that's going to be a big title at the top. I'm going to add a caption where I basically say who's authoring the plot. This is going to appear at the bottom right-hand corner of the plot. Subtitle will appear below the main title. Again, this is me saying the data source from the year. I can give, and so this is what I use my labels function to do. I add another annotation, which is the label for the x-axis, which is GDP per capita. And then on the y-axis, I add a label that says frequency. So this is going to add a lot more stuff to the plot to make it richer. And we see a much better looking plot. It has title at the top, subtitle, y-axis, x-axis both labeled. And then I've got down here my attribution of who did what. Okay, I got the data from PRB, but I'm the one that created the plot. And again, this is something that if you're spending the time to make something, you know, you're the author, let people know who the author is. Okay, I think that's something that people don't give enough credit to themselves sometimes. So I encourage you to do that. So you end up with this nice plot here. You may notice the strange notation on the Xplot. This is, whenever R sees big numbers, it will automatically jump into scientific notation, which is, it can be frustrating sometimes. So there's a package called scales that you can use different types of scales, like monetary scale, certain decimals, certain weird numeric formats that you can change the display of how these numbers are, because these are in millions of dollars or thousands of dollars, right? So this is, the scale is kind of big here. What we can do here is I can take my plot that I've made, I'm going to simplify it a little bit and only have a main title and a label for X. And then I'm going to add this, which is an additional annotation to the plot. which says, okay, I'm going to scale X, which is the X-axis. It's a continuous variable. The labels are going to come from label dollars. So it's going to take whatever that variable is that's making the it's calculating the histogram of, and it's going to format the X-axis to be in dollars. And sure enough, we run that, and it looks a lot nicer on the X-axis now. It's no longer in scientific notation, and it's a prettier plot. Okay. So again, there's loads of these things that different annotations you can add to plots to make them have different labels, have different formats. There's this one annotation that I always have to look up. I can never remember it, which is when I want to take the labels on the X-axis, and instead of having them being landscape, I want to rotate them. I can never remember how to do that for the life of me. I've done it 1,000 times, but I cannot remember the code to do it. And I've got it bookmarked. I Googled it, and somebody else told me how to do it. And it'll take the X-axis labels and rotate them a given rotation. So you can do a lot of stuff with these things. And that's what the grammar graphics book, the Ggplot book, is really good at, showing you all the different things you can tweak in Ggplot plots. Likewise, we can take this, and if we want to say plot different histograms for a different group. Okay, so we might want to go and let's say we want to compare GDP per capita, or let's say we want to compare the infant mortality rate between African and non-African countries. Okay, so I'm going to make a new variable in the data set, and there were some questions related to this last night, is sort of how you can prepare data for analysis. A big part of preparing data for analysis is cleaning it and recoding it. This is an example of recoding. Okay, so I'm going to add a new variable called Africa to the data frame. I'm going to assign the values of this variable to whatever's on the, this is called the assignment arrow. So whatever's on the right-hand side of this arrow will then be put into this Africa variable. So I'm going to use the if-else function. This is conditional logic. So I'm going to say, okay, if PRB continent equals Africa, this is what the double equals means. Is it equal to? It's like a comparison. So if you want to see what that looks like real quick, we can do PRB $ continent equals and you see this is what R looks like inside. When I ask it double equals Africa, it's going to evaluate true or false depending on if that row comes from an African nation. Okay, so this is not African nation, not African nation. This third one is an African nation. Okay, so this is sort of the conditional logic part of this comparison. And this is something else we can talk about. You know, this is a whole bunch of stuff that we're not going to cover necessarily, but I've got other resources that I can point you towards if you want. So if this is true, so if the yes clause is true, if it's true, yes, then I'm going to label the continent, the particular row, as coming from Africa. If it's not true, I'm going to label the Africa variable as not Africa. Okay, so I'm going to create two groups: African nations and non-African nations. Okay. So then I'm going to take Ggplot again. I'm going to define my aesthetic. The thing I'm going to make the histogram of this time is the infant mortality rate. I'm going to take a geomet histogram, but this time I'm going to have the bars of the histogram be different colors depending on the values of this new variable I've created, Africa. Okay, and so you can do this with any grouping variable. Yeah, 1 second, I can drop that in for you. So this is day one notes going into the chat again. So this is a great way to create different plots based off, or color the plots based off a variable and a secondary variable in the data set. Okay. I could just have it. Let's see what happens if I just do this. Okay. I'm going to make my new variable, and let's see what happens if I just do that. Okay, so this isn't great, right? It's all these values are sort of overlapping each other. We see that maybe the more extreme values are occurring more in Africa than non-African nations, so we can maybe see that. But it would be better if we could maybe plot these things side by side with each other. That might be a better way to see things. So again, there's a few different things we could do here to make this a little bit clearer. So what I do in the code here is I use this facet wrap function. Facet wrap is going to take the different levels of the grouping variable, the Africa variable here, and it's going to make one plot for non-African nations and a second plot beside the first one for African nations. I go and add titles and subtitles and labels, and I end up with this, which shows very clearly that African nations have a much higher distribution of infant mortality rates compared to non-African nations. You see this really peaked histogram of non-African nations and very, very low infant mortality rates. There are some that are high, but it's much more the case for African nations to have higher infant mortality rates. Okay. So this is called a facet plot. And you can facet on multiple different variables. And again, in some of the things I'll show you later towards the break, I'll show you examples of faceting on multiple variables simultaneously to create multiple plots on the fly really quickly. Okay. Another way to show this distribution would, instead of using a histogram function, we can use a density function, which calculates the probability density function and smooths it. So you end up with a sort of a smoother picture of the distribution of a given variable. So I like to use these a lot. Sometimes it's easier to pick out patterns compared to histograms. Histograms can be kind of clunky looking sometimes. That's a technical word. So here I'm going to make a density plot. Again, I'm going to color this. I'm going to color the variables by continent this time. So I'm going to, again, here's my data set. My aesthetic that I'm mapping is a TFR, which is the fertility rate of the country. The color, I'm going to let the color of the densities be different depending on which continent the country is in, okay? So there should be 6 because Antarctica is not in the data, so there's 6 continents in the data. The statistic I'm going to be mapping is the density, which is the normalized density, number of observations in a group divided by the total number of observations in the group. So it gets like the probability density function for this variable. I'm going to add the density geometry to draw the lines. I'm going to add the titles and subtitles and a label on the x-axis. And you end up with this, which looks kind of like colored spaghetti, right? It shows the distribution of the fertility rate by different continents in the world. And again, you can see like Europe has the lowest for most European countries have very, very low fertility rates. Say South American countries have a pretty wide distribution, while the fertility rates for African countries is a lot more variation, and the average is higher. You can really see central tendency here. You can see overall variation. You can see a lot of things from this. This is kind of like a histogram. It's just a smooth version of it, so it's not as lumpy looking as a histogram is. Okay, it smooths the categories of the data. That's a density plot. Another common geometry that's used to show distributions of variables are stem and leaf plots, or blocks and whisker plots. The two are kind of synonymous with one another. And this is going to take the data, and I'm going to have the x-axis represent the continents and the y-axis represent the fertility rates. So I'm going to, this is now a bivariate plot. So I'm plotting the fertility rate by continent. The geometry I'm going to be using are box plots. So it's going to show the distribution, the 5-number summary distribution of each of the fertility rate for each country aligned with each other. I give it a title and a subtitle, and you end up with this kind of plot. Okay, so this shows again, this is like if we have our density plot here, but it's like imagine you were standing on top of it, looking down at the densities. You would see something like this. Okay, which is kind of a weird thing to do, but you're seeing the overall placement of the distribution to the fertility rate of these different continents compared to each other. Okay, it's just a different perspective than the density plot or the histogram gives you. It shows what's being shown here are the dark lines, the medians. This is the first and third quartiles, and then I think you have the 95th and 5th percentiles plotted here. And if you see a dot here, these are what you'd call like a statistical outlier, meaning they're really an extreme value for that for this particular continent. So there's one Asian country that has a very, very high total fertility rate compared to the rest of Asia. So this is a nice way again to see both the differences and central tendency that is shown by these dark bars here, but also the overall variability between continents or between groups in your data. It's a nice way to see that. If you don't like the way this is portrayed, you can flip the coordinates. So I have basically the same plot here. Everything's the same, but I add one more argument to the bottom, which is coord flip, and it changes it. So now the x-axis is the y-axis, and the y-axis is the x-axis. So sometimes, depending on what you're visualizing, you may want to sort of flip your world a little bit and look at things in a slightly different perspective. And this is one quick and easy way to do that, just to look at how the relationships are viewed from a slightly different way of looking at them. Okay. I can also add color here. I could color the boxes by a given variable. Here I'm going to use a new function, and this is getting a little bit into dplyr. Okay, there's a couple of things in this plot that are coming from dplyr. One is this little function right here, which is called a pipe. But you notice what I'm doing here is in my ggplot statement, I'm not naming a data set. And this is coming from dplyr, which we're going to get into in just a few minutes after the break. But here, the dplyr package allows you to take a data set and pipe it into other functions so that you only have to name the data set once. And everything that comes after that will use that same data set, unless you tell it to use a different data set. So here, I'm going to use a couple of different dplyr elements. One is the pipe, and one is this function mutate. Mutate is how you create a new variable in a data set in dplyr. It's one of a few different ways. But I'm going to make this new variable in the data set called new name. And the new name that I'm going to generate is going to come from two existing variables, the continent variable and the region variable. And we can see what this looks like over here. So every row in the data has the continent that it belongs to, and then within each continent, it has a region variable that subdivides the continent into sort of smaller geographic areas. Okay. So I'm going to take these and I'm going to combine the continent name and the region name together. I'm going to take those two strings and paste them together. That's the function that I'm using here. It's called paste. So I'm going to paste continent and region together, and between them, I'm going to put this little dash. So that's going to be a new variable data set called new name, and it's going to be the combination of the continent name and the region name separated by a dash. Then I'm going to take that. This is a new variable now, and I'm going to pipe it into my ggplot statement. My x-axis is going to be defined by this new combination of continent and region. Well, I'm still plotting the distribution of the fertility rate, and I'm coloring each plot by the color that the continent that it comes from. And we'll see what this looks like. It looks good. You might be kind of freaked out right now, but it's going to look nice. I'm going to make box plots. I'm going to flip the coordinates so it looks like this, and then I'm going to give it a label. And this is what you get. So what we have here are this new variable that I created, which is a combination of the continent variable and the region variable. Some continents only have one region. I can't do anything about that. Say here's North America. It has three regions actually: North America, Central America, and the Caribbean. Okay, so here's the distribution of the fertility rate in those three different sub-geographic regions. Here's Europe: Western Europe, Southern Europe, Northern Europe, Eastern Europe. Okay, I could change this. I can do it simpler. I can go over here. Let's make it a little bit simpler because I actually don't need to do that. I could actually cut out that whole step. I could call this region, and I could end up with the same plot, I think. Yeah, but it's not ordered right now. Okay, it's not exactly ordered right because I've got I haven't sort of grouped variables by continent yet, and so I've got these green boxes here that are all European that aren't lining up. I want them to be grouped together. So actually, this paste function here actually serves a purpose to order or sort the data by continent. I wonder if we can. I don't want to monkey around too much with it right now. So this is actually serving a purpose here. And you can see both the continental variation, the variation between our larger groups, Europe, North America, Asia, Africa, and then you can also see the subcontinental, smaller regional variation between subregions within a continent. So you can. This is a way to really view the variation in a more finer grained fashion. Scatter plots are, again, if you have two continuous variables, something that you'll do a lot of are scatter plots. The geometry used here is the point geometry. Here's a few different applications using the PRB data. So here I'll take the PRB data, put it in a Ggplot. My x-axis is going to be the fertility rate, and my y-axis is going to be the infant mortality rate. My geometries are going to be point geometries. So this is just going to plot the relationship between the fertility rate and the infant mortality rate. Nothing else. Everything else is just annotations. Okay, so this is a pretty basic Ggplot. Okay, so sure enough, here we go. We see that there's a pretty positive relationship. As the fertility rate increases, so does the infant mortality rate. This is not a lecture on demography. We could go into why that might be. But you see overall there's a positive relationship. Okay, if you want to sort of measure statistically what that relationship is, it's really easy to overlay a statistical model fit over the top of the data to show the linear or the nonlinear relationship in a data set. So I can overlay a linear regression, or I can overlay a spline regression. And if you're wondering what a spline is, it's just a nonlinear function that you can fit to data. Instead of assuming everything is always linear, splines allow you to model things as nonlinear functions. They're really, really handy. You don't have to assume things are linear all the time. So here we're going to do that. We're going to do a couple of things here, and I'm going to stack a bunch of stuff together. So again, I'm going to map my fertility rate versus my mortality rate. I'm going to do a point geometry. So this is not new. This was the previous plot, right? But I'm also going to add a smooth geometry, okay? Smooth geometry here is going to come from a linear model, which is a linear regression. Okay, this is a regular linear regression model here. The line that's going to be plotted is going to be a black line, and I'm not going to plot the error in the regression. I'm just going to plot the mean line, okay? I'm also going to add another smooth geometry. It's going to be a blue line, and this is going to come from a lowest regression, which is a nonlinear regression method. Okay, it's a locally reweighted regression function that allows you to see nonlinear patterns of data. I'm not going to plot the error in it either. And then I'm going to add annotations. So I can add a bunch of stuff to a plot, right? I'm not just constrained to adding one thing and one thing only. I can stack a bunch of things together if I'm building plots. And I can end up with this. Okay, so this is comparing a linear trend to a nonlinear trend in the relationship of these two variables. Okay, so it looks pretty linear, except for maybe the extremes where the linear part kind of maybe dies off a little bit. But this is a quick way to add sort of a statistical summary of the relationship to the plot automatically. I've seen other annotations that you can take, say, the equation from the regression line and put it on the plot. If you wanted to say what the equation of the line was, slope and intercept, you might want to do that. You might not want to do that. Let's say I wanted to color the points by continent. Again, within my aesthetic, I can allow the points to be different depending on which continent they come from. I'll redo everything. Again, fertility, infant mortality, I'll have the dots to be colored differently by what continent it is. Point geometries, add a line. And what it did is it actually added a line for every continent separately. So it allows the regression line to be different based off which continent you're in. Which, if you're a statistics nerd like me, this is the analysis of covariance in one plot. So it allows you to see the relationship between these two variables for every continent on the same plot, and allow the regression lines to be different depending on which continent you're on. And you see that in most places, it's a positive relationship, right? Africa, Asia, North America, Oceania, South America, they're all positive relationships. But in Europe, it's a negative relationship. So this allows you to visualize your assumptions that these two variables are all related in the same way in a simple plot. Okay, it's a really good way to sort of question the assumptions that things always work the same way, which I'm a big fan of. Another way you can get the same sort of plot is, again, using our flat facet plots, which we talked about before. Again, facet plots are nice. They allow you to create a plot separately based on grouping variables. Again, this may allow you to visualize if a relationship is constant across groups. I'm going to basically redo this plot as a facet now and see what happens. So I'm going to, again, this is all the same. Fertility, mortality, colored by continent, add points, add my linear regression line. This is where I tell R to create separate plots for every continent, and then I add labels. So here you see the data broken apart separately by continent and the regression line plotted for each one. So this is actually keeping the data honest, keeping the plots honest, so everything is always scaled the same. We can actually make the plots lie if we want. And where do you do that? Facet map. Scales is, say, free y. And what it's going to do is it rescaled the y-axis to be different for every continent. So the maximum for Africa for the y-axis is 80, while the maximum for Europe is about 9. So this is totally lying with statistics, right? I'm totally manipulating your perspective of what's going on because you're seeing just high and low values, right? This is why you always have to pay attention to the axes, okay? It's easy to fool you with different axes by making them start and stop in different places. So I would never do this. We can also see free x. Again, the x-axis has now been manipulated in a very violent way. I think we can make it just free overall and see if they'll both adjust. Yeah. So here, if you just say free, it'll make them both adjust to be minimum maximum for each continent all at the same time. So again, this is totally lying with statistics. And please don't tell anybody I told you to do this, because I would never tell somebody to do this. Okay. This is the same thing that we saw before, nonlinear and linear. Okay, so what I want to do now is take a quick break, 6:52. So you can take opportunity now to go get a drink of water or something. And I'm going to show a quick example of making a production style graphic using R. Let's go find what I'm looking for here. Okay. So this is a policy brief that another professor in our department, Rogelio Science, and I and one of our students, Aisha Valadova, did. We had done an earlier version of this. Where is it? Yeah. So we originally published this one in summer 2020, right at the end of the first wave of COVID, documenting inequalities in unemployment rates by race, ethnicity, by gender, by education. And so all this was made in R, okay? And then a year later, we came back and we redid the whole analysis with a bit more time perspective. And we went back and made some new figures. And I was very proud of this one. Okay, this is an example of a lot of stuff that we just talked about here. I have here's my rotated x-axis, so which month of the pandemic it was. I've got labels, I've got source citations. I've added a bunch of extra lines to differentiate pre-pandemic levels of unemployment, or these are jobs, these are number of employed persons in the United States versus June 2021. So what's happened more than a year later. And then I go in and add the actual difference in the total number of employed people to the plot, on the plot. It's all using R, okay? So let's go see if I can find this. So this is all on GitHub. So if you're interested, it's all there. So this is, again, loading up the data, doing some adding some new variables, merging it to state data. This is the data file that's going to do all the analysis. I do some fundamental recodes, and this is an example of using dplyr for manipulating data, which we're going to talk about in just a few minutes in the session, right? But I limit the data to be only certain years, certain ages, et cetera, et cetera. I recode a bunch of variables to re-level levels in the data. It's a bunch of stuff. This is data cleaning, right? This is data cleaning, reorganizing, and fundamental parts of analyzing any data set. More recoding, adding more variables, a lot of stuff. And this is where I start. Now this isn't plots yet. So here we go. So this is for an example of a simple plot. Okay, so I take my data. I only filter the data out to be certain race ethnic groups because some are really statistically unstable. We'll do this in a second too. I take the data and I separate the groups out by race, ethnicity, time, here month, and gender. Okay, so this is going to make an unemployment rate plot by race, ethnicity, and gender and time. Then within that, I can do a summary. So this is calculating an average. Here I'm calculating the average hours worked and the average number of weeks that they worked for each of these groups. And then here's my Ggplot, right? Ggplot, I add a line geometry in this circumstance, and I wrap it by sex. And that's going to generate a figure that looks like it's going to create a figure that looks something. Well, this is one that's separate by race and ethnicity, okay? And it's a PNG, so it looks a little weird. So this is the unemployment rate by race and ethnicity for Blacks, whites, and Latinos. This is pre-pandemic, March, April 2021 or 2020. Then it goes down, and then a year later, you're still left with inequalities in the labor market for those three groups. Okay. This fancier graph was, where's that one? Where'd it go? I can't find it right now. This is why you shouldn't look for stuff on a live call. But all these are just making different plots for different groups, highlighting different relationships in the data. But it's using these core principles of data, geometry, or data, ggplot, geometry, and then adding a bunch of annotations. And here I'm adding, like, this is a bunch of different annotations right here, where I'm adding labels, titles, captions, X and Y axes, labels. I'm generating specific colors, because these are colors that were like, these are color codes for the publisher. They're like their official colors that they publish stuff in. So they gave me the codes. I entered the hexadecimal color codes here, so I can make the lines be their sort of patented colors. So they'll be happy. And so you can end up with things like this, right? So, and all these are just facet plots. You plot the data separately from males and females. It's a facet plot. It's a line plot combined with a facet. So it's really easy to make a relatively complex plot using just a few simple ggplot statements. Okay, as long as you have your data organized. Okay. We could do a boot camp on that. Okay. Okay, so let's get back and let's talk about dplyr then, because I've already flirted with a little bit of dplyr already, but let's get in and let's look at more content with that. Okay. So dplyr has a lot of different functions in it that, again, work to produce succinct, readable, and highly functional code. You can do a lot of stuff in a very, very short amount of coding using dplyr. And the cool thing about it is you can do all these things like statistical summaries of data, like I was doing over here. Where is it? I can take and do statistical summaries of data and immediately plot it. So I can take a dplyr data manipulation, filter, summary, and then immediately put it in a ggplot and make a plot from it. So everything is, I name the data set at the very top of the whole analysis. I manipulate, filter, recode, and then summarize, and then plot. And this is, if I had to think of 90% of what I do in my own research these days, it's that. Okay, so it's sort of this really generic workflow that you can really do a lot of different things with. Okay, dplyr consists of a series of core, what they call verbs, which are action words that you can use to reshape, clean, summarize, filter, all these sort of different data manipulation tasks. You can be accomplished very, very succinctly. Like I used to use SAS. When I first learned stuff, I use SAS, and to think about all I can do with R and just like a few lines of code, I say over here, in about 10 lines of code, it might take me 50 or 100 lines to do it in SAS, if I can even figure out how to do it. R just makes things a lot denser and a lot more succinct, I think, and you can accomplish a lot of things very quickly. So we're going to combine these verbs with these things we already saw just a second ago called pipes to connect the verbs together. Okay, and so this allows you to, again, create a very efficient code where you're not constantly having to name the data frame or name variables and things. So we're going to do a quick little tour first before we jump into stuff. So we're going to be using the PRV data again. First, we're going to create a new variable using the mutate verb, which we actually already saw how to do that. Mutate verb is how you create new variables in a data frame. Then we're going to group the data by some grouping variable. This is basically, again, this is kind of like MapReduce, where you take a data set, split it into separate data sets based off some grouping variable. That's what we're effectively doing here. Then once the data are subdivided by this grouping variable, and it can be 1 or 2 or 3 or 4 different grouping variables, then we're going to apply some sort of statistical summary to the variables in the data to summarize them, to calculate something. Okay. So here we go. So what we're going to do here is I'm going to feed the PRB data. I load the library first. I load the PRB data into the mutate function. The mutate function is going to allow me to calculate a new variable. This is like a recoding step. So my new variable I'm going to calculate is called high TFR. So this is going to make a new character variable to distinguish high versus low fertility countries. Okay. So I say, okay, if my test is the TFR for the country greater than 3, which is really high, which is TFRs, replacement TFRs are 2, or TFR of 3 is still like really, really high for most places in the world. But that's just, it's just a simple choice I made. So if that's true, I'm going to call them a high fertility country. If it's not true, I'm going to call them a low fertility country. Okay. Then I'm going to pipe that into a group by statement. So this is where I'm going to take the data and I'm going to split it based off this variable that I just created. Then I'm going to summarize the data, and here I'm going to calculate the average life expectancy. So this is a measure of population health, and here I'm going to calculate the mean male life expectancy for each of these two groups of data, high fertility countries and low fertility countries. And we saw last night, you might have to, some may be missing, so I might have to put this argument in to throw out missing values. So I run this, and it generates this little table of output here, which shows me that the mean life expectancy in high fertility countries is 62.8 years, and the mean life expectancy for men in low fertility countries is 73 years. So this is an 11-year difference in life expectancy, which is huge. This is an absolute huge difference. This is like life expectancy in 1920 compared to life expectancy now. Okay, this is a gigantic difference to be in the same time and same world. Okay, walking through what this code's doing. PRB pipe says take the PRB data and feed it into the next verb. The mutate step again walks through using this conditional logic, testing if the value of the TFR for a given country is over 3, labeling it accordingly. Then I pipe it into the next verb. The group by verb, again, separates the data into separate grouped data frames. So this is sort of splitting the data into different groups. And then from that, I can calculate my summary function, which calculates the average. And you can, this function here can be lots of different things. You can have any sort of statistical summary here. I can write my own function to calculate some weird thing that I want to calculate and apply it here. I do that sometimes. It all depends on what you want to do. This is just taking the mean across groups. A slightly different modification of this is, what if I wanted to do this for a bunch of variables? Okay, so here I'm going to use a slightly different function, slightly different analysis. I'm going to expand it some. So all this is still the same. I'm creating my high and low fertility countries. I'm grouping by them. I'm summarizing. But here I'm going to do more than one summary. I'm going to calculate the number of countries in each number of observations in each high and low fertility group. Okay, that's what the end function is going to give me, the number of cases. And then I want to calculate the mean for several variables at the same time. I could do these one at a time, but that might be kind of, you can do that. How would I do that? Let's go back over here. So let's say I wanted to do that. So let's say mean or E0 female equals mean E0 female in eta RM. It's true. We have to do it for males. So I could go in here and do them one at a time, right? and this would work just fine. So here's the mean life expectancy for females and males in high and low fertility countries. But you might not want to write them all out one at a time. Instead, I can use this across function to say, what are the variables that I want to take the mean of? What function do I want to take? What function do I want to apply to each column? And then I can throw out missing values. And this is going to go through and take the mean of all these variables one at a time and add them in columns in my analytical answer here. So here is what you get if you do this across function. Here's the mean for male life expectancy, female life expectancy, GDP per capita, and the infant mortality rate. So this is nice if I want to take the mean of a mean or any statistical summary of all these variables at the same time using one line of code. And here's the number of observations in each of these two groups. Okay, this ungroup thing is customary because right now in R has split the data into multiple groups. Okay, it's customary to bring it back together. So it's instead of like 2 data frames, high and low fertility, it's going to bring it back together into an ungrouped data frame. And this is just sort of customary procedure. It'll run just fine if you don't do this. So let's get, and you'll get the same answer. It's the same thing. But it's just sort of customary procedure. I've never run into any example where it caused an error ever. But again, in the book, they tell you to do it. Other common dplyr functions that you see a lot. The filter function is something that I use a lot. Filter is going to be where you're going to filter which rows are going to be summarized. So let's say I only wanted to here, I'm going to, again, because of my high and low fertility country indicator, but I'm only going to keep countries that are in the continents of Asia and Africa. Okay, so here I'm going to say I'm going to filter where the continent variable is in. So this is a really useful function if I want to say, here's a variable, and I'm going to see if multiple conditions are true. Okay, so here I want to see if the continent is either Asia or Africa, and there's 5 different ways you can write this, but this allows you to put the possible options just in a list of values. So this is going to test to see if the continent is in Asia or Africa. And it's basically going to get rid of every country that isn't an Asian or African country. Then I'm going to go through and I'm actually going to group by high and low fertility and continent. So for Asian and African, so this is going to be an analysis for Asian and African countries, high and low fertility compared to each other. So it's like a 4-group analysis, right? I have high and low Asian, high and low African countries. And I'm going to take the mean of all these variables for those 4 groups. So sure enough, I have high, and these are high Asian and high African fertility countries, and then low Asian and low fertility Asian and African countries. So I've generated 4 different groups based off using 2 variables in my group by statement. So this is a great way to do subgroup analysis, to do sort of intersections of different types of variables that are in your data set. And that's a lot of the things I was doing in these plots I was showing you earlier were these sort of multiple group by statements. I'm grouping by time, I'm grouping by race, ethnicity. These would be, I'm grouping by race, ethnicity, time, and age group. So again, it's the same sort of thing, right? Lots of different possibilities to look for patterns within your data that you might not see if you just looked at the data as one group. Select verb allows you to keep only certain columns in a data frame. I often use this when I do a bunch of processing and I only want to keep certain columns from my analysis in the final data frame that I'm making. So here this is going to be a really simple one where I just take the data and I just select out these 4 variables. And let's say I wanted to make a new data set from it. So let's see how that might work. So I make a sub PRB is going to come from, I'm going to take PRB, pipe it into select, and just take, here, I won't even take the head. So this is going to create a smaller data set that is going to come from PRB, but it's only going to be these 4 columns. Okay. And you see it automatically identified, or automatically popped up in my environment here. I've got 210 observations of 4 variables. Country, continent, life expectancy male, life expectancy female. So this is just a way to select columns. Okay. You can combine filters and selects together. How would you might do that? Well, let's say I say filter continent equals. Okay. And now I've only got 57 observations. So these are all African countries, the same 4 variables. Okay, so you can combine all these things together. So this would be a great way to create a subset of a data set for another analysis that you might want to do. Arrange is a way to take a data frame and sort it according to 1 or more variables. So here I'm going to, again, take these 4 variables out of the data frame. And here I'm going to sort by both male and female life expectancy. So this is going to sort from lowest to highest by default. You can reverse it if you want to sort highest to lowest. By default, it says low to high. And so here is then the first 6 rows of the data frame sorted by male and female life expectancy. So these are like the lowest life expectancy for male is in the Central African Republic, but it's not the lowest life expectancy for females because Sierra Leone is a little bit lower. More dplyr summary functions that you might use. If you want to get a list of unique items and store what that list is, the distinct function is very useful. So again, if I want to get all the different levels or values of the region variable, I can just use the distinct function here. And it's not going to count them up or anything. It just gives me what they are, just which levels they are. Indistinct gives me the number of unique items. So here, if I do indistinct of the continent variable, I just get 6 because Antarctica is not in the data, so it only has 6 continents. Counting stuff is the demographer's best friend. So the tally function is, I can show you another example in a minute if you want, of using this sort of in my research workflow. Tally is a great way to count stuff. So here I can count the number of observations by continent. So I'll group by continent, then tally. This counts up the number of observations by that. I can feed multiple, again, I can group by continent and region. Let's see what that might look like. Continent and region. So this again splits out the data by more than one group and counts up the number of observations within each of those 2 group variables. You can take this and feed it into Ggplot. Again, I mentioned this earlier. Here I'll take this is like creating a poor man's histogram of continents. So I'm going to group by continent. I want to count out the number of observations in each continent, and I'm going to make a bar chart. The values in the y-axis are going to be these n's. X is going to be the continent variable. I'm going to let the color of the bars be different by continent. And stat equals identity means I'm just going to allow the bars to be whatever n is. And so I end up with this bar chart colored by a continent, showing you the number of observations within each continent. This would be a case where I'd want to wrap that x-axis to be maybe angled, because you can see the labels are overriding each other. Okay, I know this is a lot. I'm more than happy to answer questions because we're going to jump to a slightly different topic now, which is totally different, which is talking about R file types. So if people have questions right now I can answer, I'm more than happy to do so. Okay, so I'll keep chugging along then. So a very different topic entirely are, there's lots of different types of files that you will interact with when you're using R throughout your rest of your life. There's kind of, you can do different things with different types of files. So the fundamental type of file that you're going to use when you use R is a .r file. So if I go up to File, New File, and an R script, this is a blank text document. You can open it in any text editor. It's totally unformatted where you can write R code. X equals R norm 1000, hit X. I can save this code file to my computer. I can have R run it. I can highlight all the code and hit run. It will run all the code. You can type in comments. This is a histogram. And that's about all you can do. Okay. Basic code. This is basic scripting. Read data in, manipulate data, do analysis, produce output in a very, this is a great way to produce like plots. But if you don't want to save the documents, like I don't do this for teaching, I'll do this if I want to do some sort of analysis and just create output, okay? .r files are going to be a good way to do that. Another kind of file that you're going to interact with are a bit more fun, are called R Markdown Documents. And this is very similar to what I use to write all my notes for my classes. You can use this to write dissertations. There's a lot of different things you can use this for. You can use it, I made my website with it. These are R Markdown documents, okay? It's a multiple page website, all created in R Markdown, okay? So it's not just for doing statistics and things, you can do a lot of stuff with it. So when you first create this, by default, you can do a document, which is going to be something like this, okay? A presentation. So I haven't written a PowerPoint presentation in probably 5 years. I do all my presentations in R. Shiny is an interactive data visualization tool that you can host on the web. It's like a way to create dashboards. And then there's lots of templates that there's business cards, there's letters, there's all kinds of different things. There's presentation types, GitHub documents, all kinds of different things that you can create. The fundamental way is just a basic R Markdown document. This is a way to include a mixture of code and plain text, formatted text, images in a single document to produce something like we're doing with this, okay? So this allows you to create formatted text. So like this, for example, it's a level 2 HTML header. So it'll be a big, bold bit of text. This is plain text here. You can include web links. You can format bold and italics. You can insert R code chunks. So if I want to just, this is how you insert a R code chunk into a document. Insert a plot, same thing. And this whole thing, so you can write all your code, it'll be nicely formatted, and you hit knit, and we'll just go over and save this somewhere else, test. And when you knit a document, it's going to compile all the text, it's going to run all the code, and it's going to produce a nice looking document that has all this stuff inside of it. Okay, all the hyperlinks work. Again, this is very, very similar to what I'm doing with the notes for the course, right? Very, very similar, okay? And this is, for all my classes, this is how I have students turn in their homework, like this. And there's a great option where I can take this, and I'm not sure you can see it, there's a publish button at the top here. If I click on publish, there's a free online service that you register as a user, and you can take all of these and publish directly to it. And where's mine? Here's mine. This is like all my lectures from all my classes going back several years. You can tell things get better over time. The first ones are pretty rough, and then I learned more and more. They're like PowerPoint presentations. I learned more and more Markdown and more formatting, et cetera, et cetera. And so these are all our Markdown documents that I published to. And all the students in the program that have had classes with me, they all have a repository like this that has all their homeworks and stuff in it, okay? Which is a great kind of thing to have, like a portfolio of the stuff that you've done in your classes. So our Markdown files are great. They allow you to insert code, tables, figures, statistical output. You can write LaTeX equations. This is nice. This is a LaTeX equation. What does that look like? So I can write a LaTeX equation here. So I can write the actual equation in LaTeX and have it format in the final document. I do this a lot. Looks really nice. You can include code, and then you can use the code then to produce nice tables of the output, et cetera, et cetera. A more evolved version of this is called Quarto, which is which I wrote the notes for this course in. This is a relatively new publishing system that you can use with R, Python, Julia, other types of programming languages that produce a little bit nicer looking, nicer formatted documents. It's relatively new and it's still kind of evolving, but there's been this big shift amongst our users to start using it. So these are sort of basic types of file types that you can write code, but you can also write whole reports. Yeah, you can really do a lot with these things. Projects. So our projects, somebody asked last night about how you can do R with GitHub. The natural thing to do with R and GitHub is to create a project. This basically sets up a specific folder on your computer where you can centralize all your code, all your data, all your output, all your reports for a given project, and have everything point to the same location. So you're not looking all over the place on your computer for where you've stored things. I always encourage people for a given class to create an R project, and everything is centralized in that project. So like this, my project I'm working on here are my R courses. So this is a variety of different talks that I've given different places, but all the files are all organized by what talk it was, the data that I need for the documents, all these different things that I need for these different, this is like a course I did for UTSA several years ago. It's just a way to centralize a bunch of different files that are related to the same thing. Here's another one. This is a project that I'm collaborating with a colleague in public health. Same sort of thing. I've got a bunch of code here. I've got a bunch of data that is all analyzing. This is a project looking at intimate partner violence, alcohol use, and HIV in South Africa. And so we've organized all of our data. We've got our EndNote library. We've got all of our documentation. We've got our paper drafts, all in this one project. So it's all lives together, and I can always sync it to GitHub so that I can share everything with all my colleagues, and we're all working on the same thing at the same time, which is just a really nice way to make a project easier to collaborate. Our data files are just like SAS or Stata or SPSS, reads and writes its own native formats of data files. There are two big ones that you'll interact with most. One is called RDS and one is called RData. These are the extensions for the files. So RDS files allow you to take a single R object and save it to an external file. So let's see, where's that? So this, and we'll go run some code. And so here's PRB. If I wanted to take this PRB data frame and save it to a file and only have that one thing in it, I can do that. So write RDS PRB file equals PRB.RDS. Write RDS or save RDS. Save RDS. Sorry. And so now this thing, where is it? It's in R courses. So if I go over here, R courses, here's my PRB.RDS file that I just wrote out. And it only has one thing in it. A .RData file can save multiple objects. So if I had, so let's go and let's make a second data set. A PRB2 is a PRB, and I'm going to filter, let's see, continent equals Africa. Okay, so I've got two data frames now, PRB and PRB2. I could do save list PRB, PRB2 file equals all PRB.RData. Oops. Oops. Errors. Doing wrong here. I gotta name it. Why is this not working? Save list equals, gotta be C. There. Now I've got this file over here of all PRB that has both of those data files in. If I go and I do load, let's do RM will remove everything. List equals LS. What happened? Oh, what happened? Sorry, panes. And I do load all. Both of those objects are now loaded into my session. So this is doing the same example on a much smaller scale, creating two different objects. I can save, so X and Y are two different objects. If I just want to save X, I can save it in a single RDS file. If I want to save both of them, I can put them in a named list and name it, save it to an RData file. And this is reading them back in. Again, like we talked about yesterday, reading CSVs, formatting text files. There's this Haven package for reading Stata, SPSS, SAS files, reading and writing. So let's, for example, I make a data frame with X and Y in it, two variables. I can load Haven, and I can write this out as a SAS data set. So then I can send it to my friend who works in SAS for some unknown reason, and they can work on the same data that I sent them. Okay. R can so many different data formats. JSON, which is this really popular web-based data file that's used for like JavaScript. Spatial data files, shape files, any format, Excel spreadsheets, Google spreadsheets, databases, connect to SQL databases, other foreign languages like M+ or Bugs or other kind of GIS kind of data systems. It can connect and read write to all of these formats. So it's really nice. You used to have to pay for this package. There was this package called Stat Transfer that you paid like $1,000 for, and its only purpose was to take a file that was stored in one format and turn it into another format. This is free. You don't have to, there's absolutely no reason to pay money to do this when you have something like this that can read and write native formats in any language. Common useful packages and places to find them. There's lots of different packages in R. Right now, there's over 20,000 different packages that are written by people like us, users for R that wanted to do something, wrote some code, and published it. CRAN, we talked about yesterday, was like the official source that maintains active packages. They have a lot of rules about, you have to have documentation, you have to have all these different things have to pass review. There are other places like RForge and Bioconductor that are, they have fewer rules, but they're still places that people, CRAN is the only place where you can get R packages. A lot of people post packages on GitHub that they're either working on, or they might work on Windows machines, but not on Macs. So they can be a bit more in development, but there's a lot of packages that just won't pass certain checks on CRAN that you can get via the authors themselves. CRAN likes to lump things into things that are called task views. And these are big collections of packages that are grouped around a thematic area. So for example, here's some that are it's a bunch of different packages dealing with databases. So all these different packages are, if you install the task view, you'll get all these packages installed instead of typing them in one at a time. So it's a nice way to get a thematic collection of packages that you might otherwise have to install one at a time. And this is a great thing that I usually have people do at the beginning of class. Is I showed you one of these things because I used it for this class. If you for a lot of my classes, I'll go and I'll have my R code repository here. There's a bunch of scripts way down here at the bottom that are there are scripts that will install packages that I want you to have on day one for this class. So this is a class I'm teaching in the fall. This is a little script that if you run it, it will install all these packages that I want you to have that we're going to use throughout the semester for this class. Okay, so we all start in the same place. Okay. So that's really, it's a nice way to sort of organize things. And these task views are an integral part of doing that because, again, I can say install the econometrics task view, and it'll probably install 30 packages. Okay, wow, that's a lot. That's kind of the content that I had for tonight. It's a bit more than we had last night. So I think I had originally said this might be 2 hours. We're an hour and a half in. So I'm more than happy now to answer questions. I showed an example of projects that I use. I showed an example of sort of production R code, making figures and the output of them. Other questions other people have that you might want to see certain things, or there's this where did that go? Here's this link to my RPubs page that has a lot of worked examples from classes that do all kinds of different things that you might find something of value there. Yeah, if people have questions, I'm more than happy to answer them. I know this is a lot. It's important kind of to not get overwhelmed because you can really do anything you want to in R. It's really flexible, and